Welcome back to the shop and to the channel. Trying to make a little more progress here on my DIY way alignment tool. I've got this adjustable foot, I'm calling it, all ready to go. I think this turned out nice. Next, I want to concentrate on making these clamps here that would clamp the horizontals to the verticals, as well as these two here, these smaller ones. This one here is designed to clamp the level shelf to the horizontal beam, and this one right here will eventually attach to a like an articulating indicator arm, like a Noga. I've since had a second thought on how big these are going to be, so I did shorten them a little bit. Looking at this drawing here, they look kind of long, and so I have reduced them a little bit. I always like to start with the print, so I need a couple of these here that are going to be about 2 inches long, 1 inch in diameter, with two holes drilled perpendicular to each other, 2 1/2 inch holes. Now the tricky part is, I think for me, and I'll figure it out hopefully as I go, is getting these holes lined up so they are truly perpendicular. How do I hold them? How do I hold them to make that happen? This right here, not so much, because it's got a hole going through the side. It will be drilled and tapped for a quarter 20. Although one of them, I don't think I'm going to tap one side of it, because I don't know how big that Noga arm is. And looking at this drawing, these might actually not be long enough, because it doesn't really give me a whole lot of thread engagement here between that hole that's bored in there and the face of the round stock. So I think I'm going to increase that length here. Right now I've got it set for 1 inch. I think I'm going to increase that to probably 1.5 inches. That'll give me another 1/8 of an inch on the top and bottom, and that should be pretty good. I have some round bar here, some scrap from the scrap bin that is about 1 inch in diameter. The diameter of this is not critical, but I think we'll go ahead and take this, get it chucked up in the lathe. We'll machine off this mess on the end. Hopefully this stuff machines well for me, and we'll get started with these. I'll start by machining these two 2-inch long pieces, and then drilling and tapping each end. I think I'm going to drill and tap the ends first before I drill the holes, which I will ream to 502 thousandths, a little bit more than 1/2 inch. So this piece of material here just barely fits into the spindle bore of this lathe. Let's see, 2.5 inch stick out should work about there. Again, the 2 inches is not a critical dimension either. I want to go ahead and machine off this extra bit that was on the end. I do need to drill and tap for a quarter 20, but I don't know how much. Take off a little more here, go a little heavier. $50,000 step to cut. Not sure what this stuff is. Maybe it's a leaded alloy, but it's machining beautifully. Well, one more pass here. I'm going to go ahead and drill and tap for a quarter 20. Actually drilling this all the way through here, get the full 2 inches, so I don't have to turn it around and drill it from the other side. I'm going to try power tapping this. We'll see how well this goes. I don't know if I'm going to be able to power tap the other side, but what I'll do here is I'll put this in back gear. That way this gets slowed down quite a bit. Wish me luck. That should be good. I'm gonna go ahead and clean the OD of this up so it looks nice. Some of that surface rust off of there. Some used emery cloth here so it's not so aggressive. And I got a high-speed steel cutoff blade here. This is not a critical dimension again. We'll get it close. I'm going to reset my travet dial. So let's see. There's 1 inch. And there's 2 inches. That's cutting it close, eh? Is that gonna clear? I don't think it will. So rather than taking a chance on that, I'm gonna go ahead and pop this out. I just need about a quarter of an inch. Okay, there's 2 inches. Should have no problem clearing that now. Let's try some high-speed cutoff. Tool action. This stuff is machining so well that I am hopeful that this is going to work. And I'm so hopeful we're going to do it under power. That worked out much better than I would have expected. My history with this lathe. All right, let's go ahead and we'll chuck this up in here and finish this side, chamfer, and then tap this in. Yeah, I was afraid that hole was not going to be quite in the center coming to this side, but which makes it difficult to power tap. All right, that's the first one of these clamps. At least the lathe work is finished. I still need to drill the perpendicular holes. We'll do that over on the Bridgeport. I'm going to go ahead and machine the other blank and then the other two short ones for the level shelf and the Noga arm. I'll do those off camera and I'll bring you back when we're ready to start drilling holes. Okay, I've got all the lathe work done for these. These came out pretty good, except for this one. A little bit of whoopsie. I guess the hole was not quite drilled in the center. This doesn't really matter. Where this hole is doesn't really matter because I'll use this one to mount the level shelf, and yeah, so what if it's a little off center? It's not going to matter one bit with the accuracy of this tool. This tool is for reference. It's not a precision measurement tool as much as it is a reference tool. So having that a little off center, no big deal. I left this one blank on this end because I can't remember if the Noga arm that I want to get is metric or imperial threads on the end of it. I think you can get both. I'll drill and tap that later. So next up is I need to drill through holes for each of these, no problem. And then I need to drill perpendicular holes for these. As indicated in the drawing here, I need one hole this way and one hole horizontal, one hole vertical. So drilling the first hole, piece of cake. Drilling the second hole, so it is truly perpendicular to the first, might be a little tricky. Well, let me go over to the Bridgeport and let's get these drilled and the first hole of these drilled, and we'll figure out how we're going to fixture this so that we can get a perpendicular hole drilled the opposite direction. Let's go over to the Bridgeport. All right, I'm over here at the Bridgeport and we'll get these shorter pieces set up for the single through hole that needs to be drilled. So the easiest way to do that is going to be setting up a couple of parallels, and then I can set this right on top of them. I'm going to line up the end here with the edge of that jaw. Again, this is not anything that needs to be super precise. Close enough is going to be close enough. And I'll set up an edge finder here so I can find the middle of this part. Find one edge and I will zero my x-axis. Come all the way down here. Find the other end. And we'll use the half function in the DRO. Now to find the forward and back here, I'm just going to use the jaws of the vise. So we'll go to the fixed jaw first. And we'll zero that axis, or rather half that. And now I can come into the 0, which puts me halfway. And I'm going to go ahead and lock my saddle there. And same thing in the x-axis. And we'll go ahead and lock the table there. Now, as usual, I'm going to start with spotting drill. And we're going to follow this up with a 31/64 inch drill, just shy of half of an inch, but I need to lower this table. Catching that threaded hole. Let me get this one mounted up and do the same thing. Well, these did not come out great. I'm actually pretty disappointed. This one's not terrible, except for that offset hole. Pretty disappointed with that. This one here is even worse. I mean, that hole there that cross hole there went way off kilter. I should have drilled a pilot hole, and I did not. There's a good chance that I'm going to remake these because I'm just not happy with them. But for now, I'm going to press on and move forward. And now I've got to drill the cross holes in these. I think these are more critical that I get these right. So, but I got to figure out how I get that 90-degree perpendicular set of holes. I have an idea that I was thinking about while I was messing around with these other ones that I'm hoping will work. We'll find out. Let me get the tooling set up on the Bridgeport here, and we'll see what it looks like. Maybe I'll get lucky. Well, here's my super sketchy, probably not going to work setup. It might work. Anyway, I've got the clamp in a 1-inch 5C collet in a square collet block. I've set an end stop here. I have a machinist jack underneath the far edge to give it some ability. There is maybe 1/8 of an inch inside the front of this collet. So this is either going to work wonderfully or it's going to be a complete disaster. Drop a comment down below. Let me know what you think the odds are that this is going to work, because I'm not giving it 100%. It's what I got to work with. Hopefully that doesn't catch the drill, but we'll see what we're going to do here. So I'm going to drill the first hole here on the end, and then I'm going to rotate it, the collet block, 90 degrees, and move out to the end there and drill the corresponding 90-degree hole. Yeah, I don't know exactly how well this is going to go. I guess we will try to take it slow, see what that does for us. Oh, missed it. A little bit of anchor lube here. I am going to drill a pilot hole here before I go all the way through with the 31/64 drill. Question is, will anything move or will it stay? That's the key. If I can keep it from moving, then that gives me a greater degree of success. So we're going to go to a 5/16 drill. A little worried when I get to that cross hole. What kind of problems am I going to have? You want to slow down here. Oops, a little more anchor lube. Wow. Okay. Okay, that's that cross hole. All right. All right, let's move up to the 31/64 drill. Do I want to slow this? Yeah, I might. I might slow this down. 500 RPM. Well, I guess I was right. Yeah, that just ripped that right out of there. I kind of had the feeling that was going to happen. A little bummed. The question is, can I save it? I mean, I could grab on that a little bit more. I have room. All right, let me get this out of the way. Let me reset here. Clean some stuff up, and I'll bring it back. All right, take two, I guess. I've moved this in a little bit, so I'm gripping on a little bit more of this piece than I was before. I've actually rotated it 90 degrees or 180 degrees so that I could index it on, so I could get the other smaller drill in this hole, better chance of getting it lined up. Take two, sticking with my anchor lube, and this time we're going to try to go a little bit slower, especially on the downfeed. Well, I'm through now. All right, now got to get the reamer in there, and I think for that I am going to have to drop the table, so I'm going to move you out of the way to do that. All right, now to drill the cross hole, I'm going to loosen the vise. I'm going to pull this out, and we're going to rotate it 90 degrees. Move the table over. I think it's 3/4 of an inch, and we'll start all over again. All right, I am glad that that part is over, but I still have one more of these to do, which I am most definitely going to be doing off camera. So let me get this thing out of here. There's a lot of deburring I got to do around these holes. I'm just going to do that manually, and I'll bring you back when the other part's done. I finished all of these clamps, and I will say that I am less than satisfied with how well they came out. I added these knobs I got from McMaster Car. I'm going to eventually replace these with maybe something made out of brass, just so they look a little bit nicer. But yeah, I'm not really satisfied with how well these came out. I'm sure there's a contingent of viewers out there that are screaming at their phones, their tablets, computer screens, or TVs with all sorts of comments about how I don't know what I'm doing. Feel free to share those comments down below, because you're not wrong. I really don't know everything about what I'm doing, and had I needed to do these over again, which I think I am, I will do this much differently. First of all, I would not cut these to length. That was a dumb move. I would have left them long. At least if they were longer, I'd have more purchase on them in the 5C collet for when I machined the through holes. I would use a screw machine length drill for these rather than that long jobber length drill. I think at least the screw machine length would be much more rigid to drill these cross holes, and probably start with an appropriate sized pilot hole. And I was probably running the mill at the wrong speed to top it all off. And I think I would drill the cross holes here first before bother threading each end. My thought process was wrong in that if I drilled these separately, I'd end up with burrs on the inside or something like that, but that could easily be taken care of later. I think these will work, especially these two. I don't think these are going to be a problem. This is just holding the level shelf. These two right here are for the bars that go for a bar that goes across here, and the one that goes down for the third point. Are these exactly perpendicular? They're not. And is that going to be a problem? I don't know. I don't know if it's really going to affect the precision of the tool, but they're made. We'll see how they work. I do want to do one more thing though before I wrap up this video, and I want to cut the bars down for the crossbar and the center foot or the single foot, and get those all machined and see how it looks, finally sorted together. Anyway, let me go grab the material for that. I'll cut them to length on the bandsaw, and then we'll chamfer them on the lathe. And then for the one with the foot, I've got a little bit of machining that I've got to do there. So I've got the shafting material now cut down to what I think is going to be their final sizes. It could be pretty close to this. I don't think I really want to shorten this any longer than it is, because this is about the width of it would be for my South Bend lathe. But if I was going to use this on a lathe with a wider bed, then I would need this shaft here to be longer. I got the mock-up of the level shelf up here. Now the original Kingway tool for this standalone foot, there's a ball bearing or a ball welded to the bottom of it, and that's to give that spot a single point of contact, and it also allows for some misalignment. If this is flat completely on the bottom, and let's say there is some misalignment in the bedway, that means the bottom of this cylinder essentially would only be maybe resting on one side of the cylinder instead of perfectly flat. There'd be no way really to kind of get that perfectly flat. So what I will do is I'll figure out now, the next step is to put this ball bearing here on the bottom of it. What I plan to do is to machine a bore into the ball bearing and machine down the shaft here so I can get a good press fit, something I can use some Loctite on to center it in there. Now the Kingway tool and other ones I've seen then would come with a washer, a ground washer that you would put underneath it, because this ball isn't going to be as reliable either, because even though I've got that single point of contact essentially, any irregularities in the surface is going to give you some inconsistent readings. Often when we're checking a surface for, say, parallelism, whatever, that might be scraped, we'll put like a gauge block over top of it and sweep the indicator across the gauge block, because it sort of averages everything out. And that's what that washer does. Well, the version of this tool that Wes from Watch Wes Work created, he machined this, something very similar to this, if not exactly to this. It's just a little cup that then would fit underneath that ball. And inside that cup is a little bit of a countersink. Maybe you can see that little countersink there, and the ball sort of rests in that countersink. It gives it a place, I guess, to call home. Anyway, the design that Wes came up with was to weld the ball on the end of the shaft and then place it in here. And his point was, well, this could get lost, and if it gets lost, then it's kind of pointless. So there's a couple of holes here for some dowel pins that I'll then capture the ball inside this little cup. So the next thing I need to do is I need to bore a hole in this steel ball, and then once I have, I think I have a 3/16 inch end mill that I can use for that. And then once I have that bored, then I can machine down the shaft here, so it's a nice press fit, interference fit, something I can Loctite in there for sure. I don't want to have to weld it. If I have to weld it, I will, but I'd rather not. I'd rather it just be a press fit. And then this little cup has a couple of holes here for some dowel pins. And once I place those dowel pins in there, once this is assembled, that'll capture this little cup on the end of the shaft so it can't get lost. So let's head over to the Bridgeport, figure out how I'm going to fixture this and machine a hole in there. I got to find center too. All right, I think I've got a plan here to machine this ball. I've got these two parallels here that are kind of wide. I'm going to place those in here roughly somewhere in the center. And then I've got these two scraps of aluminum because I want to grab this ball, but I don't want to do any damage because this is a steel ball. I'm presuming it's got some level of hardness to it. I don't want to do any damage to these jaws. So I think if I place those pieces of aluminum there, give it something to rest on, and then we'll bring this together. This will allow the ball to get captured. I don't have to worry about the ball damaging the aluminum. I don't care about that. It's probably going to put a couple of divots in it, but I can also make this good and tight. And if it does deform the aluminum, even better, because that means I've got a good grip on it, and I think I got a good grip on it. That ain't going anywhere. All right, I need to get a center finder in the quill and find the center of the ball. All right, we have this now positioned over the center of the ball. I'm going to take this out and put in an end mill. All right, I've got my 3/16 inch end mill in here. I am going to run some mist coolant here just to keep this end mill a little bit cool. And we're going to pump this up to a couple thousand RPM. I'm going to raise this up until I touch off. I think I've touched off. Honestly, it's kind of hard to tell. Either way, I'm going to zero out my Z-axis, and I'm going to come up about 250 thousandths. It's a half-inch ball or thereabouts. So 250 thousandths for my depth. Oh boy, that ain't good. Ugh, that was a good end mill too. All right, so I'm gonna have to see if I got a carbide end mill I can put in here. I think I do. That's disappointing. Okay, well, let's try this again. Now this is a carbide 4-flute end mill. I should be able to actually run it even faster, but we're going to stay at 2000 RPM, and hopefully this will work a little bit better. Yeah, it's 100 thousandths. 225. I don't want to go to 250. I am using this mist coolant, which again I've expressed my displeasure with. This particular kind that I'm using really is coolant that I have in the surface grinder. It's probably not well suited for this purpose. What I really would like to use is some of that Cool Mist 77 or Cool Mist 78. Trouble is you gotta buy a gallon of it. And a gallon of that stuff would probably last me 3 lifetimes. So, alright, just wish I hadn't burned up that other end mill. It's double-ended, so at least I got the other half. Alright, let's get this out of here. We'll get that shaft mounted up in the lathe and machine it to fit. Alright, so I need to machine down about 1/2 inch to 236 thousandths. I don't want to go more than 1/2 thousandths over that. 236 should be a decent fit. Now that ended up boring way oversized because that was a 3/16 inch end mill. So I'm not exactly sure how we ended up getting like 50 thousandths oversized. Anyway, we're running with it. I'll have to check that collet. Maybe there was some dirt in it. Maybe just the length of that end mill gave it some run out. I don't know. Could just be the hardness of the material created this problem for me. But either case, I've got to machine about 1/2 inch, maybe 600 thousandths, down to 236 thousandths, so I get a good, nice press fit, Loctite fit of this onto the shaft. So let me face this off, and we'll start machining this down. I'm going to zero my DRO. I'm going to zero my Travadial, and then we'll come down. There's 500. We'll go 600 thousandths. 600 thousandths should be plenty. Got 225 thousandths that'll be in the ball, and the rest will be the shaft, and we'll just dial in some amounts. I'm just going to take a cut here so I can measure this for diameter. See what we're starting with here. 466 thousandths, 466. So I got 230 to come off. Let's see, let's try dialing in 50 thousandths. Do another 50. Do another 50. Could probably go heavier, but there's no point. Not for something this small anyway. Let's take another 50. And then we'll take a measurement. Yep, that's pretty hot, so we're gonna we'll take a measurement, but I'm gonna let it cool off first and then measure it again. So we're at 250, 65, 266. Sounds about right. We started at 466, we're at 266. And we're going to 236. So we have 30 thousandths to come off. So I think I'm gonna do this 10 thousandths at a time. So I'm gonna come back and touch off again. So we'll take another 10 thousandths. Also slowed down the feed rate. Okay, so unless I did my math wrong, which is entirely possible, I should be about 10 thousandths away. And we're at 225, 45, 248. So about 12 thousandths to go. 248. Okay, we'll dial in 6 thousandths here. $242, so another 6 thousandths to go. $237, so I did only dial in 5 thousandths, and I'm fine with that. I think I'll finish the rest off with some emery paper. I could still push that in. You know, I think I'm going to leave it. I think I'll be able to press that in without a problem. All right, now I want to clean up this end. I don't want this hard edge on here. So I'm going to start here with this radius tool. I just want to take off that inside hard edge, stress riser really. It weakens this. I'll come in and machine this face until the radius touches the diameter. This is not going to be critical in here. This is just to get rid of the stress riser. And now while we're at it, I'll chamfer this outside edge. And well, we'll chamfer this tip here, just a touch, and then we'll take a little heavier chamfer here. And I think that's going to do it here. We'll clean up with this emery. Really wish I could get in here a little bit tighter. Yeah, I think that'll do it. Now I'm going to go ahead and press on that ball. And might as well use my horizontal press here. And of course, by horizontal press, I mean my tailstock. All right, so put a rag down here, and we'll take some green Loctite, slather that on there good. We'll get this started on here by hand. Sorry, my hand's in the way. All right, and go ahead and press this home. All right, we have one more thing to do, and that's to mount that cup. We'll do that over at my bench vise. All right, I got the cup here, and I've got a couple of dowel pins. And what I want to do is I want to kind of start these in here. I have to use a little Loctite on these too. Start these in here, set this in position. Now what I think I can do is use this vise to kind of press these home and squeeze those in. All right, I was able to get those to seat a little better in the other vise. Sorry I didn't take you along with me, but now that's nice and captured. This gives plenty of degrees of movement. And of course, with this little notch out, it lets it go almost 90 degrees. Not quite 90, but almost 90 degrees. Let's go ahead and put this back into the rest of the device and see how it looks. All right, well, here it is. Captured in there nicely. You know, if things were going right this week, then it would not be a normal week. Because I had a somewhat minor major miscalculation. The thickness of this bottom piece is not thick enough. You can see that there's some movement there. And why is there movement there? Well, because the ball is coming all the way through this bottom. See where the ball comes through, and I believe it is protruding. It is protruding past the bottom, which means this ball is sitting on the granite, and it shouldn't be. So I've got a correction to make. Let's see, how much did I blow this by? 15. So 15, maybe a little less than that. 10 thousandths is pretty loose still. So it's between 10 and 20 thousandths. Not thick enough. So, oh boy. So what I'm going to do is I'm going to machine up a washer that I can drop down inside. Just needs to be about 20 thousandths thick. Little spacer. Well, as sometimes it happens in my workshop, things did not go quite according to plan. So I need to fix this foot. But other than that, I think I'm pretty happy with how this is turning out. You know, from a functional perspective, I'm not real happy with how these things turned out. I would like to redo them. I probably will at some point, but this imperative that this foot is not loose like this, because then I'm going to get inconsistent readings, and the point of the foot is to get that average reading. So I think I'm going to just do this off camera. I'll fix this. And then next step will be working on these levels. I've got the level shelf already, but I need to manufacture the tubes for the levels. The caps I already have, and then I need to make some brass screws here for adjusting. I've got the springs. So another shout out to PCBWay for helping me with this project. They did the CNC machining for these spreaders as well as the foot, even though I gave them the wrong, I guess I designed it wrong. I'm not sure how in the heck I managed to do that. I thought I had calculated how much of that ball would have been exposed coming through that hole, but it is what it is. They have also manufactured the shelf for me and the end caps for the vials. Ordering stuff from PCBWay is pretty simple. You just upload your 3D files and occasionally a technical drawing, and you can get an instant quote right away. Could not be simpler. In the meantime, I'm going to manufacture a little brass washer I can drop down inside there, and I'll be okay. Well, I hope you liked this video, fiascos and all. Please leave a comment down below. They are greatly appreciated. I do read them all. I don't have time to respond to them all, but I do read them all, and your input is appreciated. And of course, a thank you to all those that have subscribed to the channel. If you're not a subscriber, hit that subscribe button. It does help out the channel and the algorithm. Hit that like button. Those are always greatly appreciated. And if you'd like to support the channel in other ways, there's some links down in the description that'll give you some options on how you can do that. Well, that's it. Thanks for watching. I'll see you on the next one.